If the nth term of a sequence is given by 4n plus 5, then we need to check whether if this particular sequence is an arithmetic progression or not. If it is an arithmetic progression, then we'll have to obtain the first 4 terms. So let's begin. So here we'll start with a given sequence. So here we have an, which is given by 4n plus 5. So what we'll do, before checking out whether if it is an AP or not, let's try to find out the first 4 terms. So we will find out the first term. For that, we are going to consider the value of n to be equals to 1, such that a1 will be equals to 4 times 1 plus 5. So this value is going to be equals to 9. Then we'll compute the second term, which will be n equals to 2. So a2 will then become 4 times 2 plus 5. So 4 times 2 is 8. 8 plus 5 is 13. Then we'll obtain the third term. So our third term will be for n equals to 3, which is a3 equals to 4 multiplied to 3 plus 5. So 4 times 3 is 12. 12 plus 5 is 17. Then we will compute the fourth term. So our fourth term will be a4, which will be equals to 4 times 4, which is 16, and 16 plus 5, that's 21. So that means the sequence is given by 9, 13, 17 and 21. So this is the sequence, the first 4 terms of the sequence an equals to 4n plus 5. Now what we need to do is we need to check whether if this particular sequence is an AP or not. For that, what we'll have to do, we'll have to find out the common difference. So to find out the common difference, all we have to do is take the second term, which is a2, and from it we will subtract the first term or the previous term. So 13 minus 9, so this is going to be 4. Right. Then we will also find out the other common difference. That means we will consider the third term and we're going to subtract the previous term, that is the second term from it. We'll subtract 13 from 17, and this is also going to give us 4. And finally, we will find out the common difference. We'll subtract the third term, which is 17, from the fourth term. So we're 21 minus 17. So this is also giving us the value 4. We observe that all of the 3 common differences are the same. So we can say that this particular sequence is an AP, and the first 4 terms are in AP. So it's evident that the other terms are also going to be in AP. Let's move on to the next problem. Problem number 2. So the nth term of a sequence is given by 2n squared plus 1. We need to check whether if it is an AP or not. So let's begin. Then this time we have our sequence given by n squared, 2 times n squared plus 1. So let's label this as equation number 1. So what we'll do, we'll obtain the first 4 terms. Let the first 4 term, the first term will be for n equals to 1. That means we will have a1 equals to 2 times 1 squared plus 1. That's going to give us the value 3. Then we'll obtain the second term. For that, we'll place n with equals to 2. So that means we have a2 equals to 2 times 2 squared plus 1. So 2 squared is 4. 4 times 2 is 8. 8 plus 1 will be equals to 9. Let's obtain the third term. For this, we're going to consider the n value to be equals to 3. So we have a3 equals to 2 times 3 squared plus 1. So this will be equals to, so 3 squared is 9. 9 times 2 is 18. 18 plus 1 is 19. Then we'll also compute the fourth term for n equals to 4. So we have a4 equals to 2 times 4 squared plus 1. So 4 squared is 16. 16 times 2 is 32. 32 plus 1 will be 33. So we've obtained the 4 terms. So this is the sequence with the terms being 3, 9, 19 and 33. And now that we have obtained the sequence, so let's obtain the value of a2 minus a1. So here we are subtracting the first term from the second term. So this will be equals to 9 minus 3, which gives us the value 6. Then we will compute a3 minus a2. That means we will subtract the second term from the third term, which is 19 minus 9. This is giving us the value 10. And we will compute the value a4 minus a3, and subtracting the third term from the fourth term. This will be 33 minus 19. So this is going to give us the value 19. This is going to be 14. Now clearly we see that a2 minus a1. This value is not equals to a3 minus a2, and this is not also equals to a4 minus a3. So we can clearly say that the given sequence 2n squared plus 1 is not in AP. Let's move on to the next problem. Problem number 3. Now we have the nth term of the sequence is given by 2n plus 7. So let's begin. We have a sequence an given by 2n plus 7. So we're going to label this as number 1. Now we'll compute the first term by taking n value to be equals to 1, which gives us a1 equals to 2 multiplied to 1 plus 7. So 2 plus 7 will be equals to 9. Then we'll consider the second term. For this, we are going to consider n value to be equals to 2, such that a2 becomes equals to 2 times 2 plus 7. So 2 times 2 is 4. 4 plus 7 is going to be equals to 11. Then we have n equals to 3, which is going to give us the third term. So we have a3 equals to 2 times 3 plus 7. So 2 times 3 is 6. 6 plus 7 is going to give us 13. And for the fourth term, we will consider n value to be equals to 4, such that a4 becomes equals to 2 times 4 plus 7. So 2 times 4 is 8. So 8 plus 7 is going to be equals to 15. Now we have obtained the given sequence, which has the first term of 9, the second term is 11, the third term is 13, and the fourth term is 15. So this is our sequence. Now what we'll do, let's name them. So this is a1, this is a2, the second term, the third term, 13 is the third term, and 15 is our fourth term. Now what we'll do, we'll compute a2 minus a1. So this will be 11 minus 9, which gives us the value 2. Then we'll compute a3 minus a2, which is 13 minus 11, giving us a value 2, and a4 minus a3 gives us the value 15 minus 13. So this is going to give us the value 2. Now we see that each of the case the difference is the same. So we say that the common difference is equals to 2, and hence we can say that our given sequence is in AP. Let's move on to the final problem. Problem number 4. So here the nth term of a sequence is given by 2n squared plus n plus 1. We need to check whether it is an AP or not. So let's begin. So here we have our nth term given by 2n squared plus n plus 1. So we compute the first four terms. So for n equals to 1, our first term will be a1 equals to 2 times 1 squared plus 1 plus 1. So with 2 plus 1, which is 3, 3 plus 1 is going to give us the value 4. Our second term will be for n equals to 2. So we have a2 equals to 2 times 2 squared plus 2 plus 1. So 2 squared is 4, 4 times 2 is 8, 8 plus 2 is 10, 10 plus 1 is 11. Then we have n equals to 3. So that's going to give us the third term. So a3 will be equals to 2 times 3 squared plus 3 plus 1. So 3 squared will be 9. 9 times 2 is 18. 18 plus 3 is 21. 21 plus 1 is going to give us 22. And n equals to 4 will give us the fourth term. The fourth term is 2 times 4 squared plus 4 plus 1. So 4 squared is 16. 16 times 2 is 32. 32 plus 4 is 36. 36 plus 1 is 37. So that means our sequence. We have obtained our sequence. This is given by the first term, which is 4. So let's go to a1. We have our second term, which is 11, a2, and we have our third term, 22, which is a3, and the 37, which is our fourth term. Now we'll compute a2 minus a1. So this is 11 minus 4. So that gives us the value 7. Then we'll compute a3 minus a2, which is 22 minus 11, giving us the value 11. Right. And we have a4 minus a3, which is 37 minus 22, and this is giving us the value 15. So we clearly see that there is no common difference here. Each of the difference are different from each other. Hence we can say that our given sequence an equals to 2n squared plus n plus 1 is not in AP. Right. It's a sequence, it's a general sequence, but this particular sequence is not in arithmetic progression.